beyond the helipause, where the sun's influence fades into interstellar space. Voyager 2 was anticipated to drift through emptiness. Sparse plasma, weak magnetic fields, random particle noise, no structure, no intention, no interaction. That was the model. That was the assumption. Then came the pulse. At first, it appeared like a minor fluctuation in plasma data, the kind engineers attribute to turbulence in a medium so thin it barely qualifies as matter. But the pulse did not dissolve into randomness. It returned. It repeated. It carried rhythm. And rhythm does not belong to chaos. Then something emerged in the data approximately 500,000 kilometers from the spacecraft. Not cataloged, not predicted, not drifting passively. Its movement did not match cometary vectors or inertial debris patterns. It shifted, it adjusted, and shortly after, a structured binary burst embedded itself within Voyager's own telemetry stream, not generated by its systems, not matching any onboard routine. The deeper the analysis went, the worse it became. The signal carried geometric symmetry, frequency inversions centered on hydrogen's base emission line, a waveform nearly identical to an anomaly recorded decades earlier by Voyager 1, magnetic distortions forming toroidal structures, and a synchronized electromagnetic disturbance that aligned precisely with Voyager's transmission delay window. The final transmission did not end in noise. It ended after structure, and that is what stopped the world. To understand why, we begin with the movement, the one thing that should not have existed in that region of space. Voyager 2 had already crossed the helipause, entering a region defined by sparse interstellar plasma and weak magnetic gradients. Its plasma wave instrument was designed to detect fluctuations in charged particle density and field oscillations. But what it recorded broke expectation. A brief spike appeared in the plasma data. Sharp, rhythmic, structured, not diffuse turbulence, not stochastic variation, a pulse seconds long, distinct. Initial assumptions leaned toward instrumentation degradation or cosmic ray interference, both reasonable for a spacecraft operating far beyond its intended lifespan. But the anomaly did not behave like hardware failure. It repeated, not identically, but with recognizable timing intervals. The waveform displayed internal rhythm inconsistent with natural plasma turbulence in that region. Interstellar plasma typically produces irregular broadband disturbances. This spike carried modulation. Repetition changed everything. A single anomaly can be dismissed. A pattern recurrence demands explanation. Each pulse maintained structural coherence rather than degrading into chaotic drift. The signal's amplitude and frequency remained within consistent bounds, suggesting an underlying driver rather than random excitation. In a region where randomness is the baseline expectation, structured repetition is statistically disruptive. The silence had been broken. As plasma fluctuations were analyzed, trajectory modeling revealed something even more concrete. Approximately 500,000 kilometers for Voyager 2, sensor readings suggested the presence of an object-like anomaly. There were no cataloged bodies in that region, no expected cometary paths, no known debris clusters. Yet, the data indicated localized interaction consistent with a discrete source. Its velocity profile did not align with inertial drift. Its vectors shifted in measurable increments, not abrupt accelerations, but subtle adjustments inconsistent with purely gravitational influence. Beyond the helipause, gravitational forces are weak and uniform. There are no nearby massive bodies capable of inducing such controlled redirection. More unsettling was the relational motion. When Voyager executed minor trajectory micro-adjustments, the object's relative vector changed after measurable delay intervals, maintaining orientation without rapidly closing distance. It was not a collision course. It was not retreat. It was synchronization. Gravitational drift does not mirror behavior. Solar wind drag does not adapt. Passive debris does not maintain relative vector alignment across trajectory corrections. Yet the data indicated that this object adjusted in response to Voyager's motion. At that moment, the anomaly shifted from environmental disturbance to interactive phenomenon. Voyager was no longer simply recording background plasma. It was sharing space with something that moved. Shortly after the object-like anomaly stabilized at roughly 500,000 kilometers for Voyager 2, something even more disruptive occurred. A radio burst appeared embedded directly within Voyager's outgoing telemetry stream. It was not transmitted on a separate carrier frequency. It was not an external broadcast detected independently. It was layered inside the spacecraft's own signal. Engineers immediately ruled out internal origin. The pattern did not correspond to any known onboard diagnostic routine, memory dump, or flight software sequence. The binary segmentation was deliberate, clean, organized, not fragmented like radiation corruption. The packet alignment maintained consistent spacing, and the inserted burst displayed structured grouping rather than noise contamination. If it had been interference, it would have disrupted carrier coherence. It did not. Voyager's primary signal remained stable. Instead of distortion, the anomaly appeared as an embedded architecture within the stream. The binary cluster did not overwrite data randomly. It occupied space with alignment and symmetry. The most striking element was the segmentation itself. The bits were grouped in organized intervals, forming repeatable patterns rather than chaotic strings. There was internal order to the sequence. The burst behaved less like static intrusion and more like encoded insertion. At that moment, the anomaly crossed a threshold. Plasma disturbance could be environmental. Motion could be anomalous. But structured binary embedded within telemetry demanded a different category of explanation. The signal was no longer just physical. It was informational. When the binary burst was mapped and visualized through frequency domain analysis, its internal architecture revealed something even more unsettling. The sequence displayed geometric symmetry when plotted across amplitude-time correlation models. It was not a simple digital repetition. It formed proportional structure. The modulation centered around a frequency inversion near hydrogen's baseline emission line. A detail that carries significance because hydrogen's 1,420 MHz spectral line is often theorized as a universal reference frequency in astrophysical communication models. The waveform's narrowband characteristics matched theoretical models of artificial narrowband emission far more closely than broadband natural plasma radiation. Natural plasma and noise tends to disperse across wider frequency ranges. This burst remained tightly confined, maintaining coherence rather than spreading. Its structure also contained modulated spacing intervals that when converted into waveform geometry displayed proportional alignment consistent with non-random encoding. The signal was not long in duration. It was not overpowering, but it was precise. The document emphasizes that this was not conclusively artificial. It does not make that claim. What it establishes is that the burst does not match known natural plasma wave phenomena or typical cosmic radio interference patterns. It was structured, localized, embedded, and aligned with a hydrogen baseline inversion. The transition from plasma anomaly to binary geometry transformed the event from physical disturbance into potential communication architecture. And once structure appears inside signal, silence is no longer an explanation. As the structured binary burst embedded within Voyager 2's telemetry was dissected, analysts initiated a cross-comparison with archived deep space mission data. The objective was simple: determine whether anything remotely similar had ever appeared before. What surfaced was not a confirmation of novelty, but something far more unsettling. Decades earlier, Voyager 1 had transmitted an anomalous signal event that was ultimately classified as noise. At the time, the irregularity did not persist long enough to trigger extensive follow-up investigation. The data processing capabilities available then were limited compared to modern analytical frameworks, and the anomaly was dismissed as interference or system artifact. When that historical dataset was reprocessed using contemporary signal modeling and pattern recognition tools, structural similarities emerged. The rhythmic grouping, modulation characteristics, and waveform spacing aligned closely with the binary architecture observed in Voyager 2's recent transmission. The correlation was not superficial. It extended into frequency behavior and temporal segmentation patterns. The most significant implication was not that Voyager 2 had produced something new. It was that Voyager may first have recorded the same phenomenon years ago, and it went unrecognized. The anomaly was not unprecedented. It was overlooked. Detailed comparative analysis revealed that both events shared near identical modulation rhythm and structural cadence. The oscillation intervals followed comparable spacing ratios. The modulation envelope showed symmetry and amplitude transitions. Even in narrow-band confinement properties exhibited parallel characteristics. What makes this alignment powerful is temporal separation. These two spacecraft were operating in different spatial regions and at different times. Yet the structural signature appeared consistent. The match was not exact duplication, but architectural resemblance. The waveform behavior followed the same logic, the same proportional modulation, the same rhythmic grouping. The document emphasizes that the earlier Voyager 1 anomaly had been dismissed due to insufficient contextual data. It lacked repetition. It lacked corroboration. Now, with Voyager 2's transmission echoing those same structural elements, the historical anomaly gained new weight. A single event can be dismissed as statistical noise. Two aligned events separated by time and space challenge that dismissal. The narrative shifted from isolated incident to recurring phenomenon, and recurrence introduces continuity. When a phenomenon appears more than once under similar structural characteristics, the burden of explanation intensifies. Voyager 2 did not just transmit an anomaly, it validated one. As the structured binary burst and historical alignment were confirmed, magnetometer data from Voyager 2 revealed an additional layer of anomaly. Local magnetic field readings began showing toroidal distortions, ring-like configurations forming in the field topology surrounding the spacecraft. These were not broad interstellar fluctuations. They were localized magnetic deformations consistent with field compression and redirection in confined space. The distortion intensified during the same window in which the binary burst was embedded within Voyager's telemetry. Magnetic amplitude increased in measurable increments. The structure of the field shifted from uniform gradient to curve containment geometry, forming what analysts described as toroidal shaping rather than linear fluctuation. In interstellar space, magnetic fields are typically weak and diffuse. They do not spontaneously form compact toroidal structures without localized energetic drivers. Yet, the data showed precisely that a magnetic reconfiguration coinciding with the plasma spike and the binary burst. The field did not collapse chaotically. It reshaped, and that reshaping occurred in proximity to the object detected approximately 500,000 kilometers from Voyager's position. The magnetic anomaly was not independent. It was synchronized. The most unsettling observation followed shortly after. During a communication window, the interval accounting for Voyager's signal delay back to Earth, an electromagnetic pulse was recorded. This pulse did not originate from Voyager's onboard systems. It was external to the spacecraft. Its timing aligned precisely with the communication latency period between transmission and reception. The synchronization was not approximate. It matched the expected delay interval. The pulse intensity briefly elevated magnetic field readings and plasma oscillation amplitude before subsiding. The object-like anomaly maintained relative vector stability during the event, neither accelerating away nor approaching. This phenomenon became informally labeled the phantom pulse, not because it was invisible, but because it did not correspond to any known emission source, solar disturbance, or interstellar shock. It appeared reactive. Its timing suggested awareness of Voyager's transmission cycle without evidence of conventional detection hardware in proximity. The document does not claim intent. It does not conclude artificial agency. What it establishes clearly is temporal synchronization between the pulse and Voyager's communication delay window alongside magnetic distortion and structured signal insertion. The plasma spike began a mystery. The binary burst deepened it. The historical match reinforced it. But the phantom pulse, synchronized, magnetic, reactive, is what transformed an anomaly into global event. Voyager 2's final transmission did not end in silence. It ended after response. Voyager 2 was never meant to make headlines in its final years. It was expected to fade quietly, its plutonium power declining, its signal thinning into static, until one day it would simply stop speaking. That was the natural ending we all imagined. Entropy winning. Instead, its final transmission forced the scientific community to pause. It began with a rhythmic plasma spike in a region where only sparse, weak interstellar fields should exist. It continued with the detection of an object-like anomaly approximately 500,000 kilometers away. Not drifting inertially, not following known gravitational vectors, but adjusting its relative position in measurable increments. Movement where stillness was predicted. Then came the embedded binary burst, structured, segmented, geometrically coherent, layered directly inside Voyager's own telemetry. Not random corruption, not system malfunction, a narrowband modulation aligned around hydrogen's baseline emission line, matching theoretical models of artificial signal confinement more closely than natural plasma behavior. When historical data from Voyager 1 was reprocessed, the pattern reappeared. An anomaly once dismissed as noise now revealed structural similarity, not coincidence, but recurrence. 2 spacecraft, 2 eras, 1 signature, and finally the toroidal magnetic distortion and the phantom pulse. A localized electromagnetic event synchronized precisely with Voyager's communication delay window. The magnetic field did not simply fluctuate. It reshaped. The pulse did not occur randomly. It aligned with transmission timing. If you want to follow every new development, every reanalysis, every signal interpretation that emerges from this event, stay with us. Because sometimes the most important discovery isn't what we see. It's what reacts when we send a signal into the dark. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.